This time on Captain Cash's Laboratory, we're going to be working on the Halloween Haunted Rails dining car, and as you can see by the note, it doesn't light up anymore. So this was sent in, and this doesn't need to be repaired. It's just so we can take the power from the train, send it to here, and find out exactly why this isn't working. So we're going to unpackage it, get it set up, and we're going to see what's going on with that car. Be back momentarily. Alright, so we took the car out of the package, and it was rattling when I opened it, and it's rattling because the little chimney broke off. Not a big deal, glue will fix that. I put the engine away because I only need the power. I used to have many of these pieces a long time ago, and all you need to do is just hook the power right in, and there's no light. Like it says, you can kind of see in there it's dark. So technically I only needed the power supply, but that's okay. And even that I didn't need. But anyway, let's figure out how we're going to get into this thing and work on it. So it looks like the access point is right here and here. So it's hard to see. See if I put a little light on it here. Might be too bright, but we'll see. There's a seam right in there, right at the bottom. That one might be easier to see. There's a line, and then if you kind of look behind the trucks, you can see hollowness. So not that one, but on that one. There's nothing back there. So, because the rest of this is pretty solid, and that clunking you hear is the light right there. So it's not another piece broke off inside or something. It's just the way it's built. Because the rest of this is just a solid piece of cast porcelain. So there's no other seams. There's paint lines. There's paint lines. There's paint lines. We literally have seams right here. Right here. You can see the seam right here. And then they resined it for the cord. And then same over here. The seam's not as pronounced because there's a big glob of paint that they ran across it. And then there's resin or hot glue for the cord. So to do this, you're definitely going to need a heat gun. And there's a really good chance, if you have these pieces, whether it's this specific engine or any of the other ones that have lights inside of them, you're going to chip the paint. And that's one of the downsides of porcelain. So I'm going to fire up my heat gun. I'm going to set it for 250 Celsius. There you go. And we're going to see what we can do about separating this. But before I go to the next step, I want to look inside and see the light. So I'm going to use an otoscope so I can fit it inside here and I can take a gander at what's going on. I can just see the black resin that holds everything in. I see the wires, and then I see let's see the black resin are painted, probably painted black so they could not have any additional color reflection. But I see the wires. I don't see any breaks in the wires. If you have really good eyes, you won't need anything that magnifies it like this, but this also shines a light in there, which makes it a little easier for me. And they're really cheap. You can get them at Walmart for like 10 bucks. This is like the best window to look in. So I'm just reusing it right now to shine a light in, and I'm using magnifiers on my head to look in through the roof where there's this hole here, and I see the wires. I see they're coiled. I see the resin. I see another wire that's just kind of off to the side. It looks like there might be a solder junction. There it is. The wires are soldered together. There's the LED, or a LED. It probably has multiple. I see it stuck inside the resin, or glue, whatever they used. So, and it looks like I'm going to try and take off probably this one first. It has a bigger seam. So the one which is on this train car, it's the on yours too. It should be the one with the female connector, because the stickers really don't. They can put the sticker on any part. I've seen this. I think mine, the sticker was like right here when I had it. But it is what it is. It's no big deal. It's just a sticker. Go. What I'm doing right now is I'm not one general area. I'm just slowly starting to heat up the entire area so we don't get a big temperature differential between one side and the other and cause us to crack. I'm trying to fix this, not make it worse. You can put foam underneath this if you're doing it at home. Be careful though, the heat gun will cause it to smolder. That's why I don't have the foam under it. It's because I'm going to be heating so much of the area. Well, I'm probably going to pause this. This is going to take a long time because I'm heating it slowly. The glue is turning clear and shiny, which means it is starting to break down. But I don't know how much goes underneath it, so this might take a half an hour of sitting here like this and slowly heating the area, and you're probably going to get bored stiff. So I'm going to pause the video and continue, and then when I find out how much time it takes to do this, I'll let you know what to expect. Like I said, I can see the glue here, and then the wheels starting to get shiny. That'll let you know it's getting hot and it's starting to liquefy, but I don't know how much it penetrates underneath. So, and make sure when you're doing this you don't melt your wires, so be careful. Don't point it right at it for too long. and don't rub it up against your heating component, whether it be a heat pen or a heat gun. Hair dryer will not be hot enough to do this. Some things can come far with a hair dryer. This one probably will not. It's just way too much surface area. And they use a lot of resin-based glues at Department 56. Less hot glues. Resin glues have a much higher temperature. So, anyway, shall return here in just a few, or whenever it's off. Alright, we're back, and I'll let you know, it took nearly, after I hit pause, it took another 2 minutes on the one side and 20 minutes on the other, because the other side had the more glue on it, the more resin. And so you're talking 40 minutes or so to do this. Trying to get my machine to cool down. I literally just got it. So, I was wrong. I thought this was all porcelain. It's not. These are resin. When they get hot, they start to get flexible. So, this is what I'm talking about. You're going to lose paint. This paint, though, was glue. This was the glue that's up inside the wells here for the trucks. One of the trucks did get a mar that you can see when it's back together. Right there. So black paint will fix that. So yeah. And then this is the side I first started doing that I got really hot that had less glue. And you can see just a little bit of marking. This side I had to get really hot. 285 degrees Celsius for 20 minutes to get this to where I could start to wiggle it and peel it. I did use a spudger to help assist and cut the glue. My spudger's all mangled up a little bit now. And then I use a screwdriver to help scrape out the light. So here's your porcelain part, just the body. Now we're going to set it over here. And it's actually easier to work on without that stack that was broke off in the package. Anyway, the reason the lights don't work is one of the lights probably shorted out. And that resistor is black. Burnt. So there might not even be power going all the way through this wire because the resistor is burnt and it may have broke. It should. It looks like they spliced it in parallel. So all they did was cut the wire here and splice this in, although it's broke, under this glue. So they just did a splice connection. The thing I saw in the middle that I said I thought was a light was actually the resistor, because the lights are literally right here on top of the trucks. So this is a mixture of resin glue on the corners and hot glue to hold in the string. So hot glue in the middle. There's a dab of hot glue here, which might have been spillover, but right where you see all the white, that's that hard glue that they like to use. And you can see it over here where it's black, and that's because they painted the hell out of it so you wouldn't see the glue. So they slathered it on and kept going and kept going and kept going until you couldn't see anything but the paint. So anyway, so this will all get cleaned up. We'll get it hot again and scrape off the remnants. The sticker side, in case you wanted to know, is the side with the light. You can't really screw up with this front or back because the wire has to come out. So it sits on there like that. And then the rear is the side that has the male connector for the next train, if it was a real train. So now I need to look up to see what color lights these were, because I don't remember, and then splice them back in. So you can kind of see here. Actually, they didn't splice them in there, they glued them in. They spliced them in the middle where the tape is. So we have the little black and white wire attached to both. The LEDs don't look bad. That doesn't mean they're not. So you can look down in the centers of the magnifier, and I'm wearing a set. And usually if you see a black dot, they're burnt. This one's good. This one looks good. Doesn't mean they're good though. But that's generally a way to check, is to see if you have a black dot in the middle of your lights. So let's just see if we're getting power through the cord to start. I know the resistor is burnt. So I know that's going to be an issue for the lights, and that's not a problem. I want to make sure that this isn't damaged. So I should be getting around 9 volts. It's a 6-volt unit, but the free float on the plug that's factory is insanely high. So it should be 988. So I know that this piece of wire is good. Now we have to go with the lights. There we go. And here's where they actually did the splicing. Yeah, that resistor is just smoked. I can kind of make out the color bands. Looks like it's orange or red and black and black. Yeah, it's hard to tell. And it might be black and green. That's the problem when they burn. That's definitely black. That one's a different shade of black. So, needs a resistor. As a minimum, maybe 2 LEDs. What I'm going to do is I'm going to research to see what the thing's supposed to look like, so I can try and figure out what color these were, and then figure out the resistance for it. But you know what? Let's just see if the lights actually work without the resistor. So how you test them? You're going to need a power supply, or you can cut them off and use a 3-volt lithium battery to see if they light up. So I'm going to assume the black is negative and the white is positive. And we're going to go about 2.5 volts just to see if we... Nothing. Resistor may have burnt because the LED may have shorted out. Let's try this one. It's got more lead. Yeah. Nothing. Alright, let's just try reversing the polarity. No, apparently the LEDs are bad. So, I'm going to assume what happened is one of 2 things. Either one of the 2 LEDs failed, causing an overcurrent, which then burned out the LEDs and the resistor, or one of the LEDs failed, causing a short, which will still do the overcurrent, but an open will do an overcurrent too, which then superheated the resistor, and then that's why it's blackened. Lastly, I guess there's a third option. Too much power. So, I've seen some people talk about this more and more recently. So, here's the power supply from Department 56. So here's the train. This is the Honda rails on it. Kind of hard to see with the light glare. Bring it up. There you go. Rickety Railroad, Department 56. So here's your power. Bring it up. Focus. 120 in. 6-volt DC out at 800 milliamp. And if you remember just a few moments ago where we plugged this in, and it was 9.88. That is a 58% increase of power over the reading of this. Now, under a load, technically it'll come down, and that's fine. The problem is sometimes when that load becomes unbalanced, we get fires or burns. I'm working on another piece that the parts just showed up yesterday. It's over here. Kind of see the edge of it right here. Right there, the brown, where all the resistors on the board are black. Not a single one is intact, and not a single one has color bands left. So I have to sit there and take the meter and test and add power to the circuit and test until I can figure out exactly what resistance I need, because I don't know the voltage draws of all the components that were connected to all the resistors. So it's taking some time. I work on it, I need a part, I order it, and I work on something else, such as this train car. So, but Department 56, for some reason, all their power supplies have a huge free float voltage, meaning no load. They're putting out 50 to upwards of 100% of their power. So I have a couple that would say like 6 volts and they're putting out 12. That's insane. LEDs don't have a lot of draw, so you're sending too much juice to them. They don't like that. They tend to burn out. Then you got these little 1/8 watt resistors that are trying to compensate, and they don't like it either because now they're generating more than 1/8 watt of heat. So they get hot and they smoke and, well, they're gone. Lemax, for the most part, if it says 4.5 volts, it usually puts out 5. So their free float is point percentage. So it's like 10, it's like, let's see, 5, that would be 11 or 12% over. I have a couple that say 4.5 and they put out 4.6 or 4.7. They're really close to accurate. I know a lot of folks don't like Lemax, and it's personal preference. I don't really care. I like them all for the pieces I collect. Mr. Christmas is the same though. Mr. Christmas has some power supplies that are 8 volt and they're putting out 9. And then I've had a few carousels come in that 8 volt and it's putting out 16. So, and then when the motor goes, which is your load, which this doesn't have a motor, your LEDs seem to get a little brighter. That's because there's no load. And then bam, they overheat, they pop, or you overpower them and they burn out. And that's what I think happened here. Something happened to unbalance the load. They did send the rest of the cars. I'm going to plug them all in once we get this one fixed, and we're going to test them all. But I want to at least work on the one that has a note that says doesn't work. That's why it doesn't work. So as far as this assembly, it's not too horrible. Take your time though. So I'm gonna watch a video or find a picture of what color they are. I think they're like a greenish color. I don't remember. I got rid of my haunted rails a long time ago because the scale was just too far off from what I collect in my village. The Lemax trains, technically the trains should be bigger than the characters, but the Lemax trains being a slightly smaller scale, they fit better in my display. Because they're closer to the HO size. These are closer to that O gauge if you're talking about real trains. And so I got rid of mine a while ago, so I don't remember what color that car was because it's been 6 years, 7 years. But anyhow, I know they're highly collectible. I know that they've been discontinued. I know they're really cool. But for what I build or my interpretation of what a village should look like, they don't match. Everybody's is different. There's no right or wrong way. So, but anyhow, I'm going to do some checking on that to see what color it's supposed to be, and then go through my LED box and see what I have that's closest to it. Because here's nothing but LEDs, and I've mentioned it in the past. You could buy a green LED today and buy the same color green LED of LEDs 1 year from today, and they'll be different colors. And that's because when they're made in batches, all that batch is like the same color. The next batch is similar, but not the same. Like paint. You buy paint, you buy all the paint you need to paint, and then sometimes when you go have new paint made, it's a slightly different hue. You may not notice it, but somebody else might notice it, depending on how they see color. So I'm going to find the closest to this in what's currently available. I'm assuming these are a little bit brighter ones because they're clear. When they have the red, green, yellow, purple lenses, they're a little dimmer. When they're clear, they're a little brighter. So it's going to be the brighter style, which I know I have. Now I just need to know if we have the correct color. Also, if yours burns out and you don't like the color, now's the time you can change it. Now, if you change them to red as an example, and these are supposed to be green, you will have to change the resistor because the forward voltage of a green LED is about 1 to 1.2 volts higher than a red LED, which means if you put a red LED on here, it's going to burn out really fast. Not necessarily within a couple of seconds, but probably within a couple of minutes. There's resistor calculators online for LEDs in case you don't know how to look them up. That way you can figure them out if you want to do changes because it's your stuff. You can modify it and make it more personal to you. I do it all the time to my stuff when I take them apart to fix them. I don't care for white lights on Halloween stuff, and when the house breaks and I have to take it apart, I will change my white lights to yellow or orange or green or red or purple, something that is more spooky than white. But I don't do that until they break because I don't feel like tearing my houses apart. Also, I don't have that much time with this time of the year, especially when I get a dozen boxes a day that I'm going through. So, but anyway, enough of the rambling. Let me do some research on this real quick for the color, see what I got for lights, make a new circuit, put it back together, test it all out. We should be done. So we'll go from there. So I'll see you soon. Alright, I'm back. I did some searching online. There is not a lot of stuff on this train car, or any of them, as a matter of fact. But I did find a video from Department 56 where it showed all the train cars, and it looked orange in the video, kind of orange or yellow depending on their lighting. But I totally forgot. Look at the box. You can see the windows are orange. You can see they're nothing. So I'm going to go with orange. I'm sure they were probably closer to the yellow hue. These are actually orange, not orange yellow. I have yellow, I have orange. I don't have yellow orange. This is a 1/4 watt resistor. It's 270 ohms. And at 9 volts, the LEDs don't get burned out and the resistor doesn't get hot. And at 6 volts, it still works just fine. So that's when you have all the trains hooked together and you have the full load. Just to show you, here is the LED. I know you can't see my machine, but the LED, I have it set for 6.3 volts, and then there you go. And then I'm going to bump this thing up to 9, which is what the free float is. Actually, it was like 9.8, so here we go. There you go. So if you plug it in directly or plug it in through the train cars, you should be fine. And this is a 1/4 watt resistor, while that one appears to be an 1/8 watt. So it can handle a little bit more stress, heat, before it starts to burn and fail. So they only taped or heat shrunk one side, which is fine. They're not the only company that does that. I usually do both, but I understand why they didn't do it. One, if you heat shrink a resistor, which generally doesn't matter, if the resistor fails and burns, like this one did, you might burn the insulation and it might get a little smoky. Usually it won't cause a fire. Heat shrink, it burns, but I don't think the resistor technically can get hot enough at such a low voltage to make a difference. So now I'm just cutting the heat shrink back so I can get to the other solder joint, which is right here. I'm going to cut the heat or tear the heat shrink off. So it's pretty simple. You do need a soldering iron. You could technically wire twist this and heat shrink it and do the same thing. Soldering iron is going to be a better connection, less likely to have corrosion in it from moisture or humidity, dirt, dust, things like that. So I'm going to do it like they did it, kind of give it back its OEM appearance. So now, if you don't have heat shrink, you can encapsulate this in hot glue. You can make a little bubble of hot glue before you stick it inside the train car. You can use tape. They use I forgot the name of this clear tape. It's the tape they use for Wrapping transformers, there's a name for it. I don't remember the name. But you can use electrical tape. You could use liquid electrical tape, as a matter of fact, which is a paint on. It'll also work if you don't have heat shrink. Technically, if you twist it and your twist is nice and tight, and because you don't have a soldering iron, you can also use liquid electrical tape to hold it in place, or regular electrical tape. You can butt connect it, or even splice connect it with like Wagos or small connectors that clip in and out. There's a lot of different ways to fix this. I know a lot of folks I talk to via the internet, they don't have a soldering iron, or they don't know how to use a soldering iron. They're not that hard. There's plenty of videos online that shows you how to use them. Most of the videos are like 20 minutes, or some are 30. They might go a little more in depth, but it's a very easy skill to pick up. If you're using leaded solder, like what I use, don't breathe the fumes. I actually have an evacuator for the fumes. I just blow outwards as I'm soldering so I don't suck in the smoke because it's toxic. But then there's also lead-free solders, which I don't use because they have a tendency of cracking. Not right away, but down the road, a year or two, the joints can crack. There's a Mr. Christmas I fixed a while back that the solder joints had failed, and that's because they use lead-free solder. So a lot of the new pieces they were for a while using lead-free solder, and then I see that they've gone back to lead. This little tool here is just a solder or a wire holder for soldering. It usually holds pretty good, but apparently this time it doesn't want to. But you put your wires in there, then you solder them together, but I'm using it as a tension so I can pull on these wires and try and break the solder. The other option is just cutting them, which would work too. If it disappears abruptly and it gets all choppy, that's because we lost power. When this video finally comes out, you will have already seen on the news that we've had some massive storms here in Arizona that have wiped out towns, destroyed lots of stuff around the Phoenix metro area, and we've had tornadoes, which is not as uncommon as people think in the desert, but they're not like the Midwest where we have Tornado Alley. We just have tornadoes. But anyway, the storm's been all day yesterday, and it's rolling right back in right now. And we're getting the sprinkles, but the storm is massive. So there is a chance that it might all cut out. It's going to get real dark if it does, because I have all the lights on. The battery in the camera should last for a minute before it cuts out. It's also powered by a wall socket, but there is a little battery inside of it to help in case something happens. It gives it time to shut down properly, because when it shuts down abruptly, it corrupts the file, and that's annoying. That's why some of the videos in the past said there was a gap, and I told you the file was corrupted, and that's because we lost power. Alright, so I just soldered the resistor in. All I did was solder the two wires back together where they broke when I pulled it apart. I folded the resistor wire over the solder, soldered it, and then cut off the excess tail. As you can see how short they cut the tail on here, I'm just going to do very similar. On this one, I'm not going to desolder the resistor. I'm literally going to cut it off and then solder it back on. Now, you can use flux when you're doing this. This is flux core solder, but if it's not holding right, you can use flux. Right now I'm just tinning the wire where I want to solder it. There we go. Yeah, the storms we're having, which looking out the window is, it's sprinkling, so it's getting close. They've been calling it, we got 7 years of rain in one day. I was driving in it for work yesterday, and well, I drive trucks, so big trucks, not semis, just large vehicles. And yeah, lots of fun. I'm not worried about the right lane flood like a lot of people are. Matter of fact, they even had the street I have to get to my house on shut down because of a sinkhole that formed from all the rain. Been a pretty good rain. It means the desert's ripe for four-wheeling. Get your vehicle all muddy, make it look pretty again. That's what I was like, oh, my truck's all clean. So, oh well. Alright, this doesn't want to solder. I think the old solder is on my way, so I'll just use that to wipe it off. I'm going to re-solder it again with new solder. Apparently the new solder didn't stick. There we go. And then hey, I know why it's not working. It's Murphy's way of telling me, hey, you're about to do this without the heat shrink, and well, that would be bad. There's the heat shrink. There we go. Heat shrinks on. Now we need to do the LEDs and cut off this tail. So I just soldered it in the center. You can see the shiny tail sticking off. Some people trim them in advance. I do occasionally, but I didn't see a need to for this one. But now it's trimmed. So now it's time to do the LEDs. So I am going to start it with a little flux because of the glue that's on here. I want to allow it to start eating through everything. Flux comes in a paste, a pen, and a liquid, whatever your preference is. I just happen to still have a pen. I also have the paste, and I don't have the liquid anymore. It's kind of a gel, not even a liquid. One. and 2. Now I'm assuming the white wire is hot, since that one has the resistor, and that the black wire is negative. And I can test that with a meter, or we got a 50% chance of being right and a 50% chance of being wrong, so let's just gamble and take our chances. So I'm going to pre-tin the LEDs where I want to solder them. We're going to tin these wires with some fresh solder, like so. LED is the long lead, is the hot, the short lead is the not, and then the LED itself is round, but on the negative side, on the actual LED lens, the clear plastic in this case, there's a flat spot to tell you it's the negative, in case you cut the leads and you forget. You can always test it. You can make a tester, use a 3-volt lithium battery to do it, like a watch battery, so you can squeeze it, but they try to give you things to help you out. Getting tired of the burning sensation, so I'm going to put this one on with a little, probably tweezers, a little bit more accurate. A little help. I guess I'll just hold it. This plastic holder is not as tight as the LED leads are. They're narrower, so I'm just gonna burn a little. There we go. And now we're gonna cut off the excess leads. And let's see if the one works. There you go. So yes, white is hot. And that's because most places put the resistor on the positive side. You don't always have to. It wouldn't matter on this one. You could put on the black side the negative. It doesn't, like I said, it doesn't care. So I got lots of different helping hands. That's what they're called. The red one I think is a wire solderer. I got it off of Temu just to try it. This one I got off of Temu as well because it was half or a third the price of Amazon. It works just fine. But I also have the other style helping hands, which I usually just get at Ace Hardware, but you get them on Amazon too. They come in handy not just for soldering. If you're doing that jewelry work where you're using wire twisting and stuff, works for that too. Bead work. So also when I glue pieces back on, if I can't hold them in the position for an hour or whatever it takes for the glue to set, like this one here, because it's flexible, I can position it. Actually, I just repaired another cha-cha, which I already have a video on, that's why I didn't film it. And to hold the lamp posts in place when they were getting re-adhered, I used these guys to hold them so that way the glue could cure. Since the problem with that cha-cha was the lamp posts. And just to make sure, while I grab the solder, plugging the solder in would do absolutely nothing. Here we go. Trim the leads. since we know it works, we're going to shrink the heat shrink. You can use a lighter, a match, you can use a heat gun, don't matter. Just whatever you have to shrink her back down. And now I'm going to coil the lights back over like they had it. I'm not going to use tape. I'm going to use a little zip tie and then cut the excess off. That's how Mr. Christmas does it. They use tape and zip ties. Tape or zip ties. They don't use them both together. Yeah, trash. Now comes the fun part. Fishing it all back through. So might have made it a hair too short. Let's try to extend it out a little bit. There we go. Yep, that's about right. Still have to clean this up. So if you've never removed glue, these flush cut wire snippers, if you don't slam the jaws shut to actually use them as cutters, the very sharp cut edge teeth work pretty good at grabbing it so you can separate it. They also can slide underneath the glue and help peel it off. Works great for soft glues. Resin glues, it works for chipping it off. Doesn't matter what the tool is intended for as long as it works. Like I said, anything can be a hammer if you smack it hard enough. Alright, now I can't get into the bottom. Just use a small blade screwdriver. Go. There. So now they're cleaned out and ready for re-gluing. That's the right one. There we go. So use gravity on a pair of pliers. Get the wires tracked through. And now we're going to put it back together with hot glue. It's going to take a minute for it to get hot, but once it gets hot, put them back on. So this one should go here. Yeah. Like So it's going to be, you can call it double glue. I'm going to fill this track with glue and stick the light in it and then the cord. So you're gluing two things at once. And then the same on this side. And then once that's together, then we'll super glue the stack on, which honestly right now makes it so much easier to work on with the stack being off. So I can lay it flat on its roof. And then we'll see what it looks like. I'll pull out the other cars and we'll make sure it looks good. So now it's just a waiting game. Just gotta wait for the glue gun to get warm. Once the glue gun gets warm, we can get this thing fixed up or finished up. So while we're waiting for the hot glue gun to get hot, the repair isn't overly difficult. I'll be honest, it would be a lot harder if that piece didn't break off in shipping, because you couldn't lay this on its flat, because it would be sticking up at an angle. But you're going to have to get it really hot. Like I said, it's about, one side took a little less time because there was less glue on it, but figure about a half an hour per side, slowly heating it up so that way you don't crack the porcelain. This part. This will just become really pliable because it's resin. You're getting it so hot, you're making the resin really soft. So, LEDs, these are 5mm LEDs in orange. They usually come in multi-packs, so you buy like 100 of them and you get like 20 orange, 20 red, 20 blue, 20 white, 20 yellow, things like that. Or 10 and they're green, blue, yellow, red, purple, pink. Anyway, you get the idea. They come in multi-packs. You could use the smaller LEDs, the ones that are 3mm. They're technically just as bright at the LED itself. It's just the range of light is less, so the distance the light travels. I have both. We're just going to put it back the way it was with the 5mm, so that way it's good. So, resistor, same thing. They come in kits, usually around 1,000 at a time. It has tons of them in there, ranging from usually as low as, some of them are as low as 1 ohm, but usually 10 ohm, all the way up through 1 meg ohm on average. So, like I said, this one's like I already forgot because I put the case away. It's either 250 or 270. But if you don't know how to do resistance calculations using Ohm's law, one of the great things about the internet is you can type in LED resistor calculator and it'll bring you a whole bunch of them that you just fill in the numbers you know, and it tells you the resistor you need. They're Ohm's law calculators. So your LEDs will be labeled the voltage they run at, and it's usually a range of like 2.0 to 2.3. It's a really short range, but it's a range. And of course 2.3 they're going to be brighter and 2.0 they're going to be dimmer. They will run lower than that. They'll just be really dim. And they will run higher than that. They'll just change color hues and then cease to exist. They'll burn out. And then you type in the amperage. A lot of them come with a milliamp rating. It's usually between 10 and 20 on average. So 10 to 20 milliamps. Some are 15, some are 12, some are 11, some are 13. Same thing. You can put in 2.3 volts at 10 milliamps and it's going to make it dim again. So you can play the numbers a little bit to adjust your intensities. And then when you do that, it then tells you what resistor you need. Oh, you also need to know your power coming in. We know this is a 6-volt system. I would put in 6 volt, but I'd also put in the free float at 9 volts and see what the difference of the ohmage is and maybe split the difference just in case you plug this car in separately and you don't want to overdrive it. So you don't want it to prematurely fail. It's got to be getting, here we go. So first things first is I'm going to fill this track up. And then before the glue gets too cool. We're going to stick the LED in, and this cord. Of course, the LED didn't stay. Do it again. I'm just going to hold it for a second. There's that one. Now, if you think that you may have broke the LED doing this, you can always plug it back in while doing it, and the LED is working just fine. So you can leave it plugged in if you want. I just don't want the cord in my way. We're going to do this one too. So if you've watched previous videos, I'll tell you anyway, if you already know. For anybody new, this is Surebonder hot glue. Some folks who watched Halloween Villages by Carl, that's what he used. I started watching his stuff, talked to him in person, since we're in the same villaging club, and sure enough, out of all the ones I've tried, Surebonder works the best for hot glue. I haven't tried anything else they make. I don't even use their glue gun. I'm just going to hold this. Maybe you can see the orange. Now, I am not going to glue this as much as the Parma 56 did, because everything breaks. So you're going to want to take it back apart. I'm not saying this one's going to break again. So instead of like encapsulating in glue, I'm going to run glue on the long edges and then center the wheels and press it down so it squeezes flat. So they put glue around the trucks, and that's why that one's chipped, because that wasn't a chip in the resin. That's the glue. When the glue got hot and I separated it, it literally, the glue's painted. So I peeled the glue off, because they paint these after they're glued. So that's one of the reasons I'm not doing it, is because you have to paint the glue. And I don't know if y'all have painted glue before. It's not as easy to paint as you think. But at the same token, everything breaks. These LEDs are supposed to last upwards of 11 years under the standard usage that they always give you, with some number that they come up with. But things happen. Maybe the LED burns out in 6 months just because it's a defective LED. It doesn't have a good connection inside when they assemble the lens and stuff. So just to help, I use the hot glue. Now, I'm not going to lie, the reason this hot glue takes so long to heat up is it has a higher melting temperature. So when you go to glue it, and then you have to heat it back up to separate it, it's not as weak as like Gorilla glue sticks or Stanley glue sticks or Ace glue sticks, the generics. This has a higher temperature, so it takes longer for my glue gun to get hot enough to do it. Even if I use a powered one, it's the same way. So it's just the way it is. But that higher melting temperature also comes in handy for like when you live where I live in Arizona. Unless say you store these in a shed, the glue doesn't dissolve from being in a 180-degree shed. So, plug that in. I'm going to go kill some lights here so you can see it. Then I'll pause the video, glue on the stack. I'm sure you all know how to use super glue if you have any village pieces. And then I'm going to pull the train out and we're going to hook it all up. So there we go. So it's not as bright as the camera makes it out to be. You can barely even see it reflecting off the white of my mat. But both lights are on. Here's one. And I kind of see the other one in this window. This one's pointing a little towards me, and the other one's pointing away from me. Lights coming back. I'd say watch your eyes, but you're not here. There we go. One light. 2 light, 3 light. We'll leave the 4th one off. Don't need it right now. So there is the Haunted Rails. Number 13, dining car. Here's the glue string. All right. So I'm going to now glue that guy back on, and then while that's curing, I'm going to open up the box and make sure the rest of the cars still work like they're supposed to, and then we're going to see what it looks like in its row of vehicles or cars. So I use Gorilla super glue. I find it binds better than super glue, or crazy glue. Also, it takes a little longer to cure, so sometimes you have to hold it longer. It's just part of it, but when it does cure, it cures really well. I'm making sure that it's centered in the crack so you don't see any of the white porcelain. There we go. So let that sit. And as far as the truck, I usually use paints like this. Sometimes I use model paint. Sometimes I use acrylic paint or oil paint, whatever matches. So while I'm letting that cure, I'll find something to touch up this chip from the glue. I know I call it a chip, but it's not a chip. It's where they had the glue. You can actually see the glue ring right in here, where the glue got peeled off because the glue got stuck to the top. And we're going to fill in that white spot so it's not so obvious. But if you have this car, or any of them, and you need to open it up, look for this seam. You saw that's what I was doing. It shouldn't fall. And I found the seam, and then you're going to have to get it hot. You can see some of the small damage right here. I'll try and touch that up. You can see where the glue oozed out right there, which is fine. It's just hot glue. It's no different than this molding that looks like bones is not bones. It's actually the hot glue curled from them sticking it together. So, but just look for seams. Doesn't matter which car it is, Caboose, the biohazard one with the skeleton, the dining car, the engine, the werewolf silver bullet one. It doesn't matter. There's always going to be a seam. They can't, especially with lights or animation, they can't assemble it in the kiln. It would destroy it. So there's always a seam. You just got to stare. You might need a magnifier or a pokey thing, small screwdriver, tweezers, needle, something to poke and see if there's a seam and if it's soft. The spudger worked. I mean, it did bend it, but you can see the hot glue and the resin glue on it from me poking and finding the soft spots to help lift. So it's not overly difficult. It's just time consuming. So, I mean, this video is over an hour to fix lights on one car, which is because I'm showing you how to do it. If you did it at home after watching the video, you could probably knock it out in 45 minutes if you had the stuff available. The longest part is separating the axle assemblies from the bottom. It took about 50 minutes for the two. That's a long time, but it was a slow heat it up so I don't crack the thin, because this bottom is thinner than the top porcelain or ceramic, so that way you don't have a shattered train car. They make a lot of super glue, and you can spend all day making that back into a 3D puzzle, but it's not going to look right. So just take your time, heat it up slowly. I increased the temperature of my heat gun from 250 to 280 slowly, and then I didn't hold it in one spot. I kept moving it, as you saw when I was showing you how to do it in the first set. Just keep going around, getting it warm until it starts to separate. And that's where the pokey thing comes in. I was poking it with this end, the pointier side, and then I started feeling it was giving way. Then I started heating around more, and I just kept a little bit of pressure on it so it would start to lift. And then I would use the edge of this and slide it back and forth. That's why it's all smeared, to cut the glue strands. So the glue they did use in here, some of it is hot glue, some of it is resin glue. They probably used the hot glue mostly for the lights and the wire, and the resin glue was used on the spots on the sides to hold the trucks on. And then they filled the gap in here with glue. Like I said, you can see it's touching here, kinda, right there, but not here. It's because the glue came out when I got it hot. If you want to reglue it and repaint it, you can. It looks, to me, it looks better without having that glue spot there, because real wheels aren't, they're not glued to the train car. So, but we got it fixed, and now we're going to test out the whole thing. So I'm going to start getting this all set up here, where we can see what this thing looks like. So if you haven't seen the haunted rails, since there are some videos online, but they're not the greatest because they're older, we're going to do a video on my bench. So it's going to be really tight bend of the cars. And we're going to do a little video of the haunted rails. So this one, this lights up. And I need a pointy thing. The wires, all right. I have that other light off, so now it's hard to see. So we'll turn that one on, see if that helps. There you go, see that shiny spot? Those are the wires. The wires go through here. And if you look, the seam is right here. Goes all the way around the front of the engine's body. So if this light burns out, the foam out, you don't have to try and figure out how to take this apart. Like these wheels, you can see the seam are stuck on the side. You just have to do it here. So things like that. You just got to look around for the different seams and where everything goes, and then you should be good. The biggest issue is going to be is the plug for this pushed inside the holes. So now I got to fish them out. So not a problem. That's why I have pliers like that. So anyhow, let me get these cars out so we can see what this looks like, so I can get this packaged up, sent back to its owner, and get the next piece on the bench for repair. Be back in just a few. Okay, I was wrong. I thought there was more train cars in there. There wasn't. This train station's in the box because it has a problem, so that'll be an upcoming video too. Most likely. Depends on if I can get it open and what the problem is. But here we go. Lights off. It's so dark. I might have to turn a background light on just to help a little. Yeah, I'm going to have to turn something on. So hold on a second. It's a little better. So, and I made a mistake. I said pull the wires at the bottom. I forgot they plug in the back of the coal car. So don't listen to that last section. So here we go. We got the fire. Of course, we got the car. And if you've never seen it, here's the front. So the pumpkin also is glued on, so you can separate the pumpkin. But that's it. So she's plugged in. That's what it looks like. I'm going to turn lights back on. Turn off that spotlight. There we go. And I did reheat the bottom truck, take it back off, and move this forward because I realized it was too short. So yeah, but that's where the plugs are. 1 and 2. Doesn't matter which one you plug it into. They're just tied to each other, and then they branch off into the light, and the light. So this concludes the haunted rail dining car and how to open it up if your LEDs burn out and take out your resistor. The train car, the engine, you can separate it here or here to access the LEDs in here. To do the power ports, you can see the big glue joint right there. That'll get you the power ports, and then it's not going to be easy, but you're going to have to heat up the top to pull the top off, and then this is glued to to the bottom here. It sticks out of the top to get inside to get to the fire. Hopefully it never dies, because this one will be a lot more labor intensive and more likely to damage the train. But like I said, LEDs are designed to last forever, so they don't, but so maybe you won't have a problem. Anyhow, thanks for watching this one. I want to put this together and look at the train station. It's got a volume issue. I've done some with volume issues in the past. There's two main problems with volume issues. If it's the blob chip, there's no repair. If it's the wheel, the volume knob, you just solder a new one in. I've shown in a couple of videos that had volume issues that were just the knobs, how to fix the knob. But we're going to take a look at it and see what we can do. That's why I said there may or may not be a video, because honestly, if it's just a new volume knob, I don't film it because I've already shown you how to replace volume knobs in the past. I don't like repeating the content. It's not really fair where you have 70 videos with the same thing. It might be a different piece, but it's the same principle. That's why if it's something strange, I'll put it in the title. But we'll see. Anyhow, thanks for watching. Till the next one. And we'll see you then. And don't forget, I still do giveaways throughout the rest of this year. I'm planning to give out, usually every couple of weeks, at least one house every couple of weeks until 2026, since that's rapidly approaching. So if you are a new viewer, look through the previous videos and see what the current giveaway is. And then you can get yourself a new piece for your display. Currently they're mostly just Christmas pieces, but I do Halloween and other Easter, Americana, fall harvest, periodically. But pretty much for the rest of this year, it's going to be mostly Christmas related. So don't forget to do that too. There's no cost to you. It's just make a comment, you win, send me your shipping address, and then within usually 2 weeks, depending on how fast the services are, a box will arrive. So, all right, till the next one.